Hello students, good morning. Yesterday we were up to this stage. The term integral p cos theta dA is called as pressure drag or also known as form drag, FORM, while the term integral tau naught sin theta dA is called the friction drag or skin drag or shear drag. Now let us continue for the same expression for drag and lift. Lift force FL on an elementary area is equal to force due to pressure in the direction perpendicular to the direction of motion plus force due to shear stress in the direction perpendicular to the direction of motion. That is equal to minus PdA sin theta. As I have already explained along with the sketch, the lift components, the pressure component as a lift are acting in the opposite direction. That's why negative sign plus tau naught dA sin 90 minus theta, that is cos theta, which is equal to minus P dA sin theta plus tau naught dA cos theta here. Tau naught cos theta. Negative sign is taken with pressure force as it is acting in the downward direction while shear force acting vertically up. Therefore, total lift FL is equal to integral tau naught cos theta dA minus P sin theta dA. The drag and lift for a body moving in a fluid of density rho at a uniform velocity u are calculated mathematically as Fd is equal to Cd multiplied by A multiplied by rho u squared by 2, whereas Fl is equal to Cl A rho u squared by 2, where Cd and Cl are respectively coefficient of drag and coefficient of lift, unitless quantity or dimensionless quantity. Okay, where Cd coefficient of drag, Cl coefficient of lift, A area of the body, which is the projected area of the body perpendicular to the direction of flow, which is equal to largest projected area of the immersed body. Then resultant force on the body Fr is equal to square root of Fd squared plus Fl squared. Following points are worth noting. What are they? In contrast to drag, the lift forces may exist even in ideal fluids by the presence of circulation. In contrast to the drag, the lift forces may exist even in real fluids by the presence of circulation. Real fluids also require vortices or circulation around the body for producing lift. So without that, lift cannot be produced by real fluids until unless there are some vortices or circulation around the body. Third point is in motion of aerofoils with finite spans, limited span, there is another kind of drag force associated with the lift force called induced drag. In case of a finite wingspan of aerofoil, there is another kind of drag force associated with the lift force called induced drag. Okay. Types of drag: pressure drag, skin friction drag, form drag, interference drag, induced drag, wave drag, etc. We will see one by one. Pressure drag. This drag is produced due to the air molecules acting in the shape of the aircraft, construction type and material. It is also produced due to the motion of the object, that is aircraft, through the fluid atmospheric air. The parasite drag can be further classified as skin friction drag, form drag, interference drag. Parasite drag, skin friction drag. The best way to understand a skin friction drag is considering a swimmer's cap. The swimmer must do more strokes in the water to overcome skin friction. Similarly, an aircraft experiences this resistance when the surface are not smooth. Thus, a skin friction drag is an aerodynamic resistance experienced by the aircraft due to contact of air with respect to the surface of the aircraft. Smooth skin reduces skin friction drag and thereby improving the performance and fuel efficiency. So the fuel efficiency and its performance will definitely improve because of the smooth skin reduces the skin friction drag. Okay. Parasite drag second type, form drag, FORM, not FARM. The drag created due to the shape and area of the cross section of the solid body moving through the fluid. This is created due to the various flow to be faced with an adverse pressure gradient. Interference drag. This drag is produced due to the interference of two or more airflow having different speed, also by the interference of different aircraft parts, such as due to a mixture of airflow around the fuselage. Profile drag. This is another type of drag. It is defined as the sum of the drag and skin friction drag. It is also many times called, this profile drag is also called as total drag. Total drag. Total drag. The portion of the wing drag that is due to turbulence and friction in the fluid that would be absent if it were a non-viscous flow. Lift-induced drag. Considering the change in vector direction of lift of the aircraft, the production of vortices is due to high pressure airflow which gets pulled towards the low pressure airflow. In such a way, lift-induced drag is produced with a lift. Pressure drag. It is caused due to the particles of air being more compressed on the front and facing surfaces and more spaced out on the back surfaces. This is caused when the layers are in the atmosphere separate away from the surface and begin to swirl. Means due to turbulent flow, the layers are in the atmosphere separate away from the surface. This is caused due to turbulent flow. Friction drag. This force is due to the resistance that happens due to two things rubbed together like an air against airplane. Friction is the reason behind the cause of drag. Even when vehicles are moving over the pavement, if you take cement concrete pavement and mud pavement, there will be more friction. In case of mud pavement, there will be more drag. Whereas in case of cement concrete, friction will be less. The term integral PdA cos theta is called pressure drag, which we have already seen, and tau naught dA sin theta is called friction drag or skin drag or shear drag. That also we have already seen. Both of these we have seen. Further on types of drag, when a thin plate is placed parallel to the direction of flow, as shown in figure, this plate is kept parallel to the direction of flow. This is the direction of flow, and this plate is kept parallel. The pressure drag will be 0, Q is equal to 90 degree, and the total drag is entirely due to shear stresses and thus equal to friction drag or shear drag only. Here only friction drag when plate is kept parallel. When the same plate is held with its axis normal to the flow direction, perpendicular to the flow if it is kept. The friction drag will be 0 because Q is equal to 0. And the flow separates at the edge, forming a turbulent wake behind the plate. In this case, the total drag will be due to the pressure force only. There is no skin, only pressure drag, and it produces a large wake or pressure wave. And the flow separates at the edge, forming a turbulent wake behind the plate. In this case, the total drag will be due to the pressure force only. When the plate is held at an angle with the direction of flow, the total drag will be equal to the sum of the pressure drag and friction drag. Thank you for watching.